مرحبا سلام. This is week 9 Physics CA. It's mostly about pressure, and other than pressure it's all old stuff يعني from term 1. Let's start. First يعني before we get into pressure, I'll do this question. The motion in which the velocity increases by equal amounts is uniformly accelerated because you're accelerating, the velocity is changing. It's easy. Let me start with pressure. Okay, pressure is actually defined as force per area. Okay, uh, and the original equation for pressure is P equals F over A. I don't know which one. I think it's A perpendicular. I'm not sure, but the perpendicular doesn't matter. Uh, what you have to know is pressure is the force divided by area. That's for the general. That's the general equation. Okay, general equation. Okay, how about pressure could also be exerted in a gas, in a liquid, and it could be exerted in the atmosphere. So scientists classified pressure into atmospheric pressure, okay, atmospheric pressure, and also liquid pressure. Okay, at any moment, actually no, I'll leave that for later. Atmospheric pressure is usually constant, and it's given in the question. It's usually 10 to the power of 5, I think. One second here. It's 100,000. 100,000 PA. PA stands for Pascal, and that's the unit of pressure. Okay, liquid pressure is equal to rho GH. Waleed, what's rho? Okay, rho is شو اسمه density. Okay, density of the liquid. G is the constant, which is 10, gravitational acceleration, and H is the height. I don't know if it has to be in meters though. Wait, uh, I think it should be in meters. It should be in meters. Okay, all units should be in meters. Okay, here I saw a lot of questions in the quiz. I think every single question, area was given in centimeters squared, but you can't use that. It has to be in meters squared. But pay attention, okay? From centimeters squared to meters squared, you don't divide by 100. You divide by 10,000 because it's squared. With squaring, it's different, okay? You divide by 10,000 if you're going from centimeter squared to meter squared, okay? The reason behind this, by the way, is because from centimeter to meter, you divide by 100, right? But since we're squaring, that means you have to square this 100 also, and that's actually 10,000, okay? يعني it would be stupid for anybody to get to get that wrong. If you're converting from cm squared to meter squared, it's 10,000. Sorry. And if you're going from centimeter to meter, normally it's divided by 100. Okay, let's start. You have the area of a shoe is 150 cm squared. The weight of the person wearing these shoes is 600 newtons. Okay, so we have the area, which is 150 cm squared. Okay, and then we have the weight of the person is 600 newtons. So this is the force. Okay, so can we find the pressure? Of course we can. P equals F over A perpendicular. So the person who doesn't care and who doesn't pay attention will put 600 divided by 150 equals 4, and I'm done. Okay. أول شيء they put 3 times 10 to the 4, so if you do this, you're gonna know immediately your answer is wrong. Okay. What do you have to do? The first thing, yeah, this is why this is a tricky question. The first thing you have to look at, this person wearing these shoes. You know, when you wear shoes, this is you, yeah? Okay, you're wearing 2 shoes, one here and one here. Excuse my drawing skills, but what I'm trying to show you is you wear 2 shoes. This is one shoe. If one shoe is 150, since we're wearing 2 shoes, that means you have 150 over here and 150 over here. So the total area is actually 300 centimeters squared. But you know we can't work with 300 centimeters squared, but we have to divide by 10,000. After you divide by 10,000, you're going to get 0.03 meters squared. For now, can we solve? Yes, we can. We can do 600 divided by 0.03, and you should get, and I'll do it in front of you so you can see, 600 divided by 0.03. Oh, that's 0.3. 0.03. You get 20,000, which is actually 2 times 10 to the 4. Okay, that's it. Let's continue. Question 3. Okay, one thing I forgot to mention. Let's say you have a glass. Okay, you have a glass like this, and you fill it with water. I'll draw it in blue. You fill this glass with water. Okay, and I will immerse an object. Let's call it object A. I'll immerse it here. Object A, we said to find the pressure of the liquid on it, you do rho gh, right? Okay, but this object A is subjected to the liquid pressure, right? And it's also subjected to the atmospheric pressure coming from the outside, because the glass is open. So it's subjected to the atmospheric pressure. If you want to find P total, which is the total pressure, it's always the pressure of the liquid plus P ATM, which is atmospheric pressure. Okay, let's solve this. The diver of mass 70 kilos swims in the salt water of density 1020. The diver is 5 meters below and USG is 10. The pressure on the diver due to the water. In this case, they're not asking for total pressure, but done pressure of the liquid, of the water. How do you find that? We do rho GH. Rho GH. Some people say I use a different unit, but in the book it's rho GH. That's not a P, that's rho. Okay? So I'm giving it to you like this. What is rho? It's a density, which is 1020. What's G? They said use 10. And H is 5. You multiply this out, you get 51,000. But they want it in kPa, kilopascals, so you divide by 1,000 and you get 51. Question 4. A small object is immersed, density 1000. The object is 2 meters below. Use G equals 10 and use the atmospheric pressure as 100 kPa. What is the total pressure? In this case بدهم P total, right? بدهم total pressure. P total قلت لكم انه it's liquid pressure and atmospheric pressure. فأول شيء let's find the liquid pressure, which is again rho GH, right? Which is equal to the density 1000 times G, which is 10, times the height, which is 2, and you should get 20,000. 20,000. And the PATM is actually 100 kPa. So this is 20,000 PA. This is 100 kPa. They want the answer in kPa, so let's convert this into kPa, yeah? Let's keep it as kPa. So you just divide by 1000 kilopascals. To make it kilopascals, it will be 20 kilopascals, kPa. Okay, since K is divided by 1000 kilo. Okay, so now can we find the total pressure? We do the pressure of the liquid, which is 20 kilopascals plus 100 kilopascals, because that's the atmospheric pressure, and you get 120 kilopascals. Okay, question 5. Okay, we have in physics something called the hydraulic press. Okay, before moving on to the hydraulic press, I want to show you that something extremely important. Okay, let's say you have this cup, again filled with water, and you have point A. Actually, I put it in green. And you have point B. This point A and B are actually on the same level. Since they're on the same level, that means they have the same pressure. This is a rule that you should have, يعني خلاص. You should know this. Same depth, same pressure. Okay, Walid, why are you telling me this? Here you have what we call a hydraulic press. This hydraulic press would be a tube fitted with two ends. Obviously, this end has a smaller area, and this one has a bigger area. Let's actually say this height is the same. I have to draw it up here. They have the same height. How they would say is, let's say you pushed the liquid here down with a force of 20 newtons. How much will the force be over here? I'm going to give you an equation. These 2 points, here and here, are at the same depth, so they have the same pressure. Same pressure. What's the pressure over here? It's F over A. And what's the pressure here? F over A. Let's call this F1 and A1, and let's call this F2 and A2. Like that, you just derive an equation. F1 over A1 is equal to F2 over A2. So what do you do? For questions like this, always use F1 over A1 equals F2 over A2. Okay? Pressure, pressure. This is the general equation for pressure. So how can we solve this if we have 20 newtons here and 4 centimeters here and x newtons over here and 50 centimeters? You do simply 20 over 4 equals x over 50. Wally, do you have to convert the units? No. If they're both centimeters squared, عادي. Okay? Cross multiply, you get 4x equals 1000 and you get x equals 250. Question 6. The force exerted due to the pressure of a fluid is normal to the surface. You could say perpendicular. What are they trying to say? Okay, the force from the pressure. Let's say you have object A. Okay, this is the surface of the liquid. Okay, it's always perpendicular. It's always like this. Okay, always in physics, it's always perpendicular. We never take anything else. You could say normal, you could say perpendicular, you could say right angle, whatever. كلهم نفس الشيء. Measuring pressure. I want to see if I can show you from this section. Manometers. Yeah. This, before I continue, this was in the book, but it wasn't in the quiz. But dams, because I remember a question. It came last year in grade 9 because we did pressure for a week. Okay. It came about this dam thing. Okay. Know that the dam is always thicker it's broader at the base, uh, and it's thinner at the top. Okay. So as you go up, it becomes thinner because the pressure as you go down increases. So as you go down, there's more pressure. So that means it should be thicker to withstand that pressure. Okay, يعني in case that comes. بس no, the thing I want isn't here. To measure liquid pressure, uh, you can use a YouTube. Okay, this is the YouTube manometer. So this YouTube, the way it goes, you have the YouTube, you have the funnel, you have the rubber membrane. يعني the liquid rises to the pressure you have. It's very simple. يعني nothing too hard. So the YouTube is how you measure pressure. But you have other cases which are asked in this quiz, and I'll show you them once we get to them. What is the pressure at point B if it's at depth h equals 12 centimeters? Okay, they're saying atmospheric pressure is 1 times 10 to the 5, G is 9.8, and P of water, this isn't P, this is rho, okay, is 10 to the 3. And density of water is 10 to the 3. What's the pressure at point B? They're asking for pressure, so they're asking for total. Okay, if they just say pressure, that means they want total. So they want liquid pressure plus atmospheric. Okay, so liquid pressure, how do we find liquid pressure? Liquid pressure is equal to rho GH, right? Which is equal to 10 to the 3. 1 times 10 to the 3 is the same as saying 10 to the 3 times G 9.8 times the height, which is 0.12. Why did you use 0.12? You must convert to meters. I told you divide by 100. Okay, plus atmospheric pressure, which is 10 to the 5. Okay, I think I remember getting 1.012 times 10 to the power of 5, and they just kept it as 1.01. Okay, uh, that's it. These questions are very, very easy. Question 9. What's true about atmospheric pressure? Difference in pressure causes winds to blow and rain to flow. I think this is pretty self-explanatory. If there's pressure, that's how is the wind gonna move? You need to have some pressure that causes the wind to move. Atmospheric pressure is affected by weather conditions. Yes, it is. It's slightly affected by weather conditions, and that's why, by the way, uh, to predict the weather, scientists use the barometer, which I will discuss in a bit. Scientists use the barometer to actually predict the weather because the atmospheric pressure changes as the weather changes. Changes in temperature do not affect atmospheric temperature. Obviously, that's wrong. Changes in temperatures cause air masses to expand or contract, affecting the pressure. That's explaining why the pressure changes if temperature changes. Because once the temperature changes, it causes the air to expand, or it causes the air to contract. If it temperature rises, air expands, causing I think temperature and pressure direct proportion, causing a pressure to increase. And if a temperature decreases, the air will contract, having a smaller pressure. No need to know that, but just take so you understand. I always give extra information and stuff. Yeah. Okay. Manometers. طيب. Manometers. How does it look? Wait. H1, H2. Okay. You have clo. Okay. Yeah. I was gonna say this is a closed-end manometer. Where you have a bulb like this, it goes down. بعدين عندك I think like this. Okay. Then it goes and it goes up. Like this. Let's call this G. And the gas. Let's fill this up. Let's fill this up to over here. And هيك بس. Okay, and it goes up to, let's say, over here. This is a closed end manometer. It's closed. Okay, so that means over here it's closed. That means here, yeah, they say here it's vacuum. Okay, what does that mean? There's only pressure acting from the liquid. Okay, there's no atmospheric pressure. So if you wanted to find the pressure of what's going on inside the manometer, since it's closed, you only take the liquid pressure. Okay, طيب. The equation they give you for the closed end manometer is the pressure of the gas is equal to rho g h2 minus h1. This is h2, this is h1. Okay, this is h2, yani this thing here, and h1 is over here. Okay, okay, you can skip this if you don't want to understand. I'm sure many of you will skip, but for those who actually want to understand why, okay, we use this manometer to measure the pressure of this gas. But the way they place it is they place a point here and they place a point over here. Okay, why? This point here measures the pressure of the gas, right? Pressure coming from the gas. And at the same time, it's kind of submerged in the water, so it will still have that pressure of the liquid. And this pressure here is actually on the same level as this. These two pressures are equal. What's the pressure of this one? This is actually equal to rho GH1. And what's the pressure of this one? It's actually rho GH2 minus H1. طيب. This rho GH is actually equal to, يعني it's showing the pressure of the gas. Okay? Rho GH2 minus H1, okay, is equal to the pressure of the gas. Okay? That's it. Why you can't do this is because it's submerged in both the gas and the liquid. If you want to solve it, it's rho gh2 minus h1. If for a closed end manometer, please. For this question, let's do rho gh2 minus h1. It's gonna be 1.36 times 10 to the 4 times g times h2 minus h1. If this is 12 and this is 60, you have to do 60 minus 12, which is 48 centimeters, so it becomes 0.48 meters. Okay, you multiply this and I think you get 65.28. Round this and you get 65.3. There should be an option for 65.3. Yes, there's. Okay, so if you want to round it to 65.3, you can put it. Question 11. This is speed. يعني زمان. How can you find the speed? You should do this point x to find the slope of the tangent. Because it's a curve, you have to do the tangent. So just find the slope of the tangent, which is this line. Okay, how can you find the slope? You have a, which is 10.5, and you have b, which is 4.0. Okay, you know that speed is actually x final minus x initial over time final minus time initial. What's x final? 0. No, it's not 0, sorry. It's going from B to A. It's actually 5. It doesn't matter, since it's speed, it's always positive aslan. 5 minus 0 over, it's finishing at 10, so 10 minus 4, 5 over 6, which is 0.83 if you do it on a calculator. Question 12. Let me do this fast. A ray of light goes from glass to air, and the angle of incidence is 30. What's the angle of reflection? It's always Ni sine I equals Nr sine R. Okay, Ni is 1.6 since we're moving from glass. We're starting in glass. Sine 30 because the angle of incidence is 30 equals Nr, which is 1 because it's in air, sine R. 1.6 times sine 30 is 0.8 actually on the calculator, equals sine R. How do you find R? It's actually the inverse sine of 0.8, and you get 52 point something. I don't know. I don't know what you get, but you should get an answer that after you round it, you get 53. Okay. Question B. The ratio of the sine to of the incidence to the refraction is constant. What is this known as? It's the second law of refraction. احفظوا, memorize. This came the past 4 AMSs. Which of the following statements describing the ray diagram are true? This lens is being used as a magnifying glass because it's the virtual one. This is virtual and upright, and it can only be seen by IQ. Yani, you should know. There was a question that came in the AMS يعني the past few weeks. I'm not going to say everybody's getting it wrong, but some people are getting it wrong. Okay, it was optics question. عادي انه they gave this وعطوك هيدي, they drew it for you. They put the lens in the middle. They tell you the object is placed, I think it was 2 centimeters away, 2 centimeters away, and it has a height of 6. And then they say the image is formed 3 cm away. What is the height? Okay, if you want to do this, it's always شو اسمه length over height, length 1 height 1 over length 2 over height 2. Okay, the way I do it, I do 2 over 6 equals 3 over x. I cross multiply, I get 2x equals 18 and x equals 9. The answer was actually 9 centimeters. The way this was deduced, okay, they used similar triangles. If you want to see how, if you don't, skip this. If you want, look, this is 2 centimeters away, okay, and the height is 6. This is forms a triangle, no? And then if the image is placed the image is formed 3 centimeters, and the height of, let's say, x, you know these triangles are similar. You have this triangle which is 3 and x, and you have this triangle which is 2 and 6. That's why you get 2 over 6, 3 over x, whatever. You get 9. But that's just in case you want to know. مهم أنا I like explaining things. For question 14, Jane has a mass 80 kilos. If he stands on 1 foot and the area is 200 centimeters squared, then the pressure is whatever. Okay, أول شيء, we know pressure is force over area, right? We don't have the force, but we have the mass. Okay, and they're saying take G is 10. If you have the mass, that means you have to convert it to the weight. W equals mg, because the force is the same as saying weight. And you know mg, you get 80 times 10, so 800 newtons. Yeah, that's to find the weight, which is the force. Divided by the area, we need the area to be in meters squared, so we have to divide by 10,000, right? So it will be 0.02. What do you get here? I think you should get 4 to the power 4 times 10 to the 4. 800 divided by 0.02. Yeah, 800 divided by 0.02. 40,000, which is 4 times 10 to the power 4. Question 15. I think there's 19 questions. The pressure is measured using a pressure gauge, whatever, and liquid pressure can be gauge, and I'll show you what type of gauge. Liquid pressure can be measured using a simple gauge, which is called the YouTube manometer. For liquids, it's manometer. Okay. Okay. This one's an I like this section. It was in the book, and I'll show you the other cases in case they come. Uh, there are cases where how can I say it? Let's start with the straw, right? They say once you suck through a straw, it reduces the pressure inside the straw. Air pressure on the liquid inside the straw becomes less than atmospheric, while the pressure on the liquid outside the straw is atmospheric. The difference in pressure causes the liquid to be pushed up the straw. In the exam, they might ask, what causes the liquid to move up a straw when you suck it? You could say due to the difference in pressure. Or you could say, it depends, it could come multiple choice, or it could come air pressure inside the straw is less than atmospheric. Because you reduced it inside the straw, and akid atmospheric is always stronger. Atmospheric is very strong. So this difference causes the liquid to be pushed. How about experiment 2? The plunger. The plunger, okay, enter when you push the plunger. Let's say this orange thing is the plunger. You have atmospheric acting down on the plunger, and then you have these small vacuum pressure, right? After you completely like press on the plunger, this vacuum is sealed and it becomes like this. Now there's no more pressure from down. Since there's no more spaces, there's no opening. For what happens? There's only atmospheric pressure acting on the plunger. For whatever you do, it's gonna stick. No matter what force you do, unless you really, because after you press on a plunger, uh, it's very hard to like click it back up. So this is why, because once you press on it, there's no more pressure acting like towards it. Now there's only atmospheric pressure from the atmosphere, from the air pushing on it. There's no more reaction. That's actually how they stick glass, by the way. Uh, and this gravity one is really interesting. And I'm not going to show you the can one. I don't think it's important. This gravity one, I think it's nice. If you put water, okay, you have to fill up the glass fully filled, fully. They might come in the exam, which is false, and they say use a glass that's half full. It has to be fully filled. Why? Once you fill a glass full of water, okay, let's say this is the water, that means there's no more space for air. So there's no more atmospheric pressure acting inside the water. It's only liquid pressure that's pushing up. And obviously there's going to be atmospheric pressure pushing down. And atmospheric pressure is way stronger than liquid pressure. For what's going to happen, I'll show you here. You have this water, it's fully filled, right? There's no atmospheric pressure since there's no openings anymore. It's all water. There's pressure of the liquid acting up. But you sealed it now with a cardboard box. So that means there's atmospheric pressure from the atmosphere acting opposite to it. So if you flip the glass upside down, water won't fall down because the atmospheric pressure prevents the water from going down. So I just wanted to show you these. And I think most of your physics teachers of the students who are watching this, they should have performed this demonstration in your class. Our teacher did it. So why does the plunger stick to the surface of the floor? Because of the atmospheric pressure, right? Since the pressure outside the sucker is greater than inside. It's way greater. There's very small pressure inside. Question 17. Okay, look. The original way, actually I'll show you from the book. The original way they measured pressure was there was a guy called Torricelli. Okay, he filled up a huge glass tube about 10.5 meters, okay, 11 meters, and he placed it in water, and the water kept going up until it reached 10.34 meters, which is equal to atmospheric pressure. Another scientist came and told him, no, Torricelli figured out this was pressure. He told him, "Top man, how inconvenient is it if every time you have to measure the pressure, you need a huge tube of 15 meters?" So he proposed to Torricelli, try using mercury. Where did he say it? He was advised by Galileo to use mercury. Why? Because it's heavier. It has a larger density. Okay? Because when we say the pressure of the liquid is equal to rho gh, we're talking about density. So the density matters. And since the density of mercury is way larger than that of water, that's why it's gonna be a smaller change in height. المهم the guy Torricelli, he changed it to mercury, and he found out that it's better to use uh, mercury to measure pressure. And he measured it as the height that the mercury moves is a unit of pressure. And he made his own unit. I don't think this will come, but in case it comes, the torr, he made the unit called torr, and it's equal to 1 millimeter of mercury, Hg. So mmHg is actually how far does the mercury move. Millimeter being the distance it moves, and Hg is mercury. There are some important remarks, yeah? The atmospheric pressure is not constant. If the pressure changes, the height of the mercury will change. You know that. Because how we measure it nowadays is we use a barometer, okay? A barometer. This is what I told you I'd come back to. And the barometer actually is this tube. It's filled with mercury down, we say Hg, and then you fill it with a tube and you measure how high does it go, okay? You measure how high does it go, and that's your pressure. Obviously that will be in a different unit, not Pascal, it will be in mmHg. بس المهم, this barometer uses mercury. Okay, if the height of the liquid changes, that means the pressure is being changed. Okay, the height of the mercury column is independent of the shape and size of the tube that's containing it. Okay, it remains unchanged if the column is tilted or lifted as long as it is fully immersed in mercury. What are they trying to say? If you, this is, let's say 2 millimeters. Tilt it, it's still gonna be 2 millimeters. Tilt it more, it's still gonna be 2 millimeters. Okay, it's gonna go up to the perpendicular distance from your container. Always perpendicular. Okay, so no matter how you change it, the height will still remain unchanged. Okay, and then they say mercury is very toxic, whatever. Uh, yeah, they're saying it's toxic, but be careful. Here they're saying mercury down here. They're saying this tube of radius 1 centimeter is placed and it rises to a height of 800 millimeters. So this is 800. If another vacuumized tube of radius 2 centimeters, the liquid will rise to 800. Why? Because I just told you, regardless of the shape, of the size, of the material of the tube, of the let's say the density of the tube, let's say the thickness of the tube, let's say at what angle you're immersing the tube. As long as you're immersing it in mercury, it's still gonna rise to the same height. Okay? Question 18. What is this? It's a barometer. Memorize this. Okay, the barometer, this is an aneroid barometer actually. Okay, an aneroid barometer. Okay, why is this aneroid? This is aneroid because there's no liquid being used. I they the way they explain it, I think you have springs. The aneroid barometer. This is the barometer. The barometer does not require a barometer that does not require a liquid is an aneroid barometer, and it consists of metal, uh, and it has springs in it. And you don't need to know because it's a bit advanced, but know that the one that doesn't have a liquid is called the aneroid barometer. And what does it measure? It measures atmospheric pressure. And what are the units? mmHg. Okay, a barometer measures an mmHg. You see 760, 770, 780. Okay, what's it called? They use this in planes to measure the weather. Pilots use it, and they also measure it to see if the pressure is right inside the plane. This was in the book. I'm not just saying this because I'm trying to have fun, but it was in the book. How long does this go? Whoa! But it was in the book, uh, and they also use it to determine the weather. What is this? It's a hydraulic press, like we had in question 5. A hydraulic press, but this is actually how it looks. Okay, it's a hydraulic press. You press here, it goes up here. Uh, they said the downward force of the 20 centimeter squared piston is 12, and the upward force is 36. What's going to be the area? We said use F1 over A1 equals F2 over A2 for 12 over 20 equals 36 over X, cross multiply, X equals 60. Thank you so much for watching. Good luck tomorrow. I know it's a lot of new stuff, but inshallah khair. Yalla, bye. Thank you so much.